Mammoth frozen mid-bite, Earth's 12-hour climate crash? When Earth rebooted and the climate reset within hours, an alternative reconstruction of paleoclimatic catastrophes based on geophysical, paleontological, and long-forgotten archival data. We may be underestimating the speed at which planetary systems can transition into new states. Introduction. Not evolution, but a phase transition. The standard model of paleoclimate tells the story of gradual change. Glaciers advance and retreat over centuries. Ecosystems shift over millennia. But what if Earth's climate behaves not like a thermostat, but like a superconductor, capable of flipping into a new state within mere hours once a critical threshold is crossed? This is the Cryogenic Switching Hypothesis, CSH, an extension of Charles Hapgood's Crustal displacement theory, now enriched with new evidence: anomalously preserved mammoth tissues, stratigraphic inconsistencies, and paleobotanical paradoxes. CSH asserts, Earth has undergone at least 3 cryogenic switching episodes over the past 100,000 years. These events involved not just cooling, but a phase shift in the planet's hydrothermal system. Instantaneous freezing is not a metaphor, it is a physical effect triggered by a sudden breakdown in geodynamic equilibrium. Stage 1. Accumulation. Earth's scales tilt out of balance. According to Hapgood, the catalyst for displacement is a mass imbalance caused by the buildup of an ice sheet over one of the poles. When ice mass exceeds 20 million kilometers cubed, as during the worm glaciation maximum, it generates a torque comparable to that of a large asteroid impact. Yet modern models show ice alone is insufficient. However, if we add resonant oscillations in the liquid core, geomagnetic excursions like Le Champ 41,000 years ago, and external gravitational perturbation, massive methane degassing from shelf hydrates abruptly altering atmospheric radiative properties, then the lithosphere mantle system can enter a regime of non-linear instability. Crucially, the crust does not slide smoothly. It snaps into place, like a pressurized lid clicking shut. A displacement of 15 to 30 degrees within 72 hours is geodynamically plausible if lubricated fault zones, ancient sutures, act as slip planes. Current GRACE satellite data have detected unexpected localized crustal shifts of 8 to 12 centimeters per year near Greenland, even though the ice sheet grew by only 3% over 20 years. Extrapolation suggests threshold behavior cannot be ignored. Stage 2. Trigger: the supercooled atmosphere effect. The core mechanism of CSH is not displacement itself, but the secondary cryogenic wave that follows it. A sudden shift in rotational angular velocity and mass distribution causes a sharp drop in centrifugal force in equatorial zones, atmospheric compression, disruption of stratospheric circulation patterns, collapse of the tropopause, ozone depletion from upper layers, ultraviolet pulse, photochemical breakdown of greenhouse gases. The result is a thermal profile inversion. The upper troposphere cools by 80 to 120 degrees Celsius within 6 to 12 hours, and the frigid air collapses downward as a cryogenic front. This is what we call instantaneous freezing. For context, a temperature of minus 101 degrees Celsius is indeed required to preserve undigested plant matter in a mammoth stomach, and such conditions are only possible during atmospheric collapse, not in a stable tundra environment. The Berezovka mammoth is not an exception, but a typical specimen. Undigested clover in its mouth indicates digestion halted within less than 1 hour. Absence of decomposition traces means tissues were sealed, before bacterial growth could begin. Hemoglobin still capable of binding oxygen? 1990s analysis, St. Petersburg State University, implies extreme rapidity in protein stabilization. Many theorists invoke rapid freeze scenarios to explain findings across Siberia, Alaska, and the Yukon. Stage 3. Evidence. When palms stand eternal guard. The strongest argument against gradual climate change is not agreement, but mismatch in paleobotanical data. Yes, palm fossils appear in Paleocene-Eocene deposits in Siberia and Tibet. Yes, they point to a warm, humid, frost-free climate. But in the same layers, transitional features leading to glacial troughs. In carbon isotopes, abrupt temperature jumps occurring in under 50 years. In pollen spectra, complete disappearance of thermophiles and sudden rise of cryophiles with no intermediate forms. This is not a transition, it is a rupture. Moreover, the Ipica ice core Antarctica records methane spikes with half-widths of just 20 years, indicating catastrophic hydrate release likely triggered by seismic disturbance from crustal displacement. CSH resolves the paradox. Siberia was indeed subtropical, not millions of years ago, but just 12,000 to 10,000 years ago. Then the last cryogenic switching phase transition occurred, and the ecosystem was frozen mid-stride. Earth is not a clockwork mechanism, but a quantum-like system. Classical geology views Earth as a clock, slow, predictable, deterministic. The cryogenic switching hypothesis says the planet is a non-stationary system with thresholds, and we may well be living in a metastable state. This is not conspiracy theory, it is a warning. If in 2025 Greenland is losing 260 billion tons of ice per year and the Arctic is emitting 12 million tons of methane annually, where lies the next instability threshold? The cryogenic switching hypothesis sits at the intersection of geophysics, paleoclimatology, and nonlinear dynamics. It does not deny gradual change, but proposes that Earth's history is dominated by rare, catastrophic transitions which conventional methods smooth out and smear over time. As Hapgood wrote, human history is the history of survivors of catastrophes. The main question is not whether the next one will happen, but whether we'll recognize the signal in time. The Berezovka mammoth is not a myth. It is the latest letter from the past, written not in ink, but in ice and cells. And it reads, "The system can reboot. Be ready." Stage 4. Subthermal signature, the cold that should have left no trace. If cryogenic switching truly occurred, its fingerprint must extend beyond shifted paleomagnetic poles or pollen spectrum anomalies. CSH predicts a unique thermodynamic artifact specific to phase transitions in open non-equilibrium systems, the subthermal signature. The phenomenon is straightforward. When biological tissues are cooled suddenly to below -100 degrees Celsius within hours, water does not merely crystallize, it forms high-density amorphous ice, HDA. Unlike ordinary ice, HDA produces no sharp crystals and does not rupture cell membranes. That is why intact mitochondria, preserved lipid bilayers, and even RNA fragments were found in the Berezovka mammoth's tissues. This is not freezer-style preservation, it is a kinetic trap. Molecules freeze in place before thermodynamically favorable degradation can occur. Such a state is physically impossible under slow cooling. Irreversible cell damage begins already at -20 degrees Celsius, and protein denaturation becomes total by -50 degrees Celsius. Yet the Berezovka mammoth's hemoglobin, after 44,000 years, still bound oxygen under room temperature lab conditions. But here lies a deeper paradox. Stomach content analyses reveal not just grass, but a full seasonal spectrum: clover, periwinkle, buttercup, and grasses like bromus and poa, species that flower at different times of year. This indicates the animal died not in hibernation, mammoths didn't hibernate, not in winter dormancy, and certainly not in transitional seasons. It died in midsummer, possibly at peak bloom. Therefore, the cryogenic wave struck not in the frozen Arctic, but in a temperate, warm, nearly steppe-like ecosystem where July mean temperatures hovered around plus 15 degrees Celsius, confirmed by stable oxygen isotope IV ratios in tooth enamel. In an instant, from plus 15 degrees to negative 115 degrees, a 130-degree drop in 6 to 12 hours. No hurricane, no volcanic plume can produce such wind chill cooling. Such change is possible only during atmospheric layer collapse, when upper tropospheric layers, chilled to negative 120 degrees Celsius, cascade downward under gravitational instability, a phenomenon known in astrophysics as an atmospheric collapse cascade, observed for example in gas giants struck by comets. Thus, Berezovka was not frozen in the tundra, but caught in a localized climatic collapse. Its body is not a skeleton in an icy sarcophagus, but a thermodynamic record, a flash drive capturing an instantaneous crash in Earth's planetary operating system. Stage 5. Cryogenic memory of ice, when ice tells the truth and models stay silent. If CSH is correct, ice cores do not merely record sharp changes, they must contain non-linear markers that modern averaging algorithms simply smooth over. Take the grip core, Greenland. Standard analysis shows a smooth temperature curve over the last 100,000 years. But switch to high-frequency decomposition, wavelet analysis at 1 to 5 year resolution, and a sharp 7-year-wide temperature plunge appears around 800 years ago. Not a gradual step, but a needle-like spike resembling a ventricular fibrillation electrocardiogram. This is not noise, it is signal. Such a profile is incompatible with slow ice sheet melt. It is compatible with a sudden change in surface geopotential, when ice in one region ceases to be polar, while another area abruptly becomes the new north. Local pressure shifts, and meteorological conditions of the drilling site reconfigure instantly. Water vapor from new latitudes, for example temperate zones, carries a different isotopic signature, and in the core, this appears as a sharp drop. Moreover, in the same interval, GRIP registers a nitrate spike 8 times above background, classic evidence of an extreme ionospheric storm caused either by a supersolar flare or a rapid shift in the magnetosphere. The latter aligns with data from the Monument Peak geomagnetic excursion, dated to 12,900 years ago. And in the WAIS Divide Core, West Antarctica, a synchronous methane spike with a 22-year half-width occurs. This is not peripheral hydrate degassing. It is a release from a subglacial reservoir ruptured by sudden crustal displacement. Imagine, a 10 trillion-ton ice sheet abruptly slides 20 degrees in latitude, generating seismic waves that shatter hydrate lenses on the shelf. Methane erupts like steam from an overheated boiler. Here, CSH diverges from the Younger Dryas impact hypothesis, or YDIH. Both YDIH and CSH account for abrupt cooling, nitrate spikes, pollen shifts, and megafauna extinction. But the key difference lies in triggered duration. YDIH posits an instantaneous impact with consequences unfolding over months and years. Dust veil, wildfires. CSH proposes a short-duration geodynamic rupture, but instantaneous consequences: cryogenic front, atmospheric collapse, and thermal shock. And the decisive proof lies in the absence of an iridium or platinum anomaly layer in pristine ice cores at the 12,800-year mark. The iridium spike exists in the Cretaceous-Paleogene boundary, the Chicxulub impact, but not in the Pleistocene-Holocene transition. Instead, there's a sharp enrichment in rare earth elements: and D, SM, EU, typical of bedrock leaching during a massive lithospheric plate landslide. In other words, Earth was not struck from outside, it transitioned to a new state from within. Stage 6. The Paleogeographic Paradox. How Siberia could bloom while Hudson Bay didn't yet exist. One of the strongest objections to a recent within 2,000 years subtropical Siberia is the absence of corresponding landforms. Where are the river valleys typical of humid climates, the lake basins, traces of intense chemical weathering? CSH's answer: they were erased. Cryogenic switching is not just a temperature regime change, it is forced ablation reglaciation. When the pole shifts, the old ice sheet does not melt, it redistributes. Massive ice masses previously covering the Canadian archipelago or Scandinavia, upon crustal displacement, suddenly find themselves in temperate latitudes and begin melting catastrophically fast. Estimates show, at a mean temperature of plus 5 degrees Celsius, a 2-kilometer thick glacier can vanish entirely in 150 to 300 years, with warm oceanic currents in 50 to 80 years. Such melting generates catastrophic floods capable of moving million-ton boulders. This is how these features formed: the channeled scablands of Washington, carved not by rivers, but by water flows of 10 to 15 cubic kilometers an hour. The Caspian lake basins, created by landslides in permafrost-overloaded lithosphere. The terraces of the Yana-Indigirka lowland, not ancient river traces, but steps of ice front retreat over just 2 to 3 human generations. And what came before that? Paleosols in Yakutia sections, for example near the Semyon-Uriak River, contain kaolinite residues, minerals that form only under high humidity and temperatures above plus 10 degrees Celsius. These soils lie beneath loess-like silts, which in turn lie under glacial deposits. Thus, 1. A warm, humid ecosystem existed. 2. Then cryogenic collapse. 3. Then hydrospheric collapse, ice sheet melt, flooding, and erosion. 4. Only then the classic glacial epoch we reconstruct today. We see only stage 4 and build a model of gradual glaciation. But that's like trying to reconstruct a fireworks display from cardboard scraps and gunpowder-scented wind. Many geophysicists reject Hapgood's ideas, noting modern GPS monitoring detects no wholesale crustal displacement. That's true if you're looking for smooth sliding. But CSH does not assume sliding. It posits cascading fault ruptures along pre-weakened zones, ancient sutures like the Urals, Taimyr, and the Trans-Siberian Fault. Modern discrete plate dynamics models show that when stress exceeds 50 to 70 megapascals, chain reactions along fault networks become possible, like a crystal vase shattering on impact. Not one smooth shift, but a series of micro jumps, phase synchronized. The result? Net pole displacement of 15 to 25 degrees in 2 to 3 days. Critics also often conflate crustal displacement with rotational axis shift. These are distinct phenomena. CSH does not require changing Earth's total moment of inertia, only redistributing mass in the upper shell. And this is confirmed by GRACE and GRACE-FO data. Anomalous mass loss near Greenland, up to 260 billion tons per year, compensated by mass gain in East Antarctica. We live in an era when the system is once again approaching a threshold. If Earth is a quantum-like system, it should exhibit threshold precursors before phase transition. What do we see today? Increasing geomagnetic excursions. Field intensity has dropped 9% over the past 300 years, and the North Magnetic Pole's drift speed has surged from 15 to 55 kilometers per year. Anomalous seismic quiescence. Sharp declines in microseismic activity often precede major events, a sign of fault locking before rupture. Arctic methane behavior. Emissions from the East Siberian shelf are rising non-linearly, tripling between 2020 and 2025. All these parameters fit the fold-saddle bifurcation model from René Thom's catastrophe theory. The system appears stable for a long time until it reaches a singular point. Then, any small perturbation triggers irreversible transition. The cryogenic switching hypothesis does not call for panic. It calls for shifting paleoclimatology from a science of the past to paleoclimatics, a science of the future. The Berezovka Mammoth is not a monument to a past catastrophe. It is a calibration standard for early warning systems. Its cells are the first sensor of phase transition. And we are the first generation capable not just of reading this letter from the past, but of replying to it. In 2024, a team from Tomsk State University discovered in Yamal's permafrost fragments of a previously unknown Salix willow species, genetically closer to Mediterranean forms than Arctic ones. Age: 160 years. The plant was found in an ice lens with no signs of decay. Flower buds were closed but not crystalline frozen. Amorphous ice. That exact kind. The signal is already on its way. We only need to learn how to hear it.